Right, so we're going to try and summarize this again with the absolute value and where you're going to have an issue with the plus or minus and how you're going to be able to take care of it with the fuzzy math. So I'll try and lay it out in 2 different sets. Okay, so for this first one, dy dx equals 2xy. If you try to quickly look at some slope fields here, anytime x is 0, 2 times 0 is 0. So anytime x is 0, it is flat. Anytime y is 0, it is flat. Anytime at the origin 0, 0, 0 times 0 is also flat. So you have flatness there. The bigger the x and the y, the bigger the number, so it's steeper. And everything in the top quadrant, top right quadrant, the first quadrant, those are all positive and a positive. So a positive and a positive would multiply to a positive. So it gets steep really quick. So all I care about is their positives. Over here, in the second quadrant, only x is negative, and so they are negatives. And again, the further away from the origin, the steeper. Over here in the fourth quadrant, only y is negative. So all of those go negatively. Steeper, steeper, steeper. And then over here, both are negative, so negative times a negative is positive. So they kind of go really rough sketch like that. Now you would do it a lot more properly by plugging in specific points and getting the tick marks for the slopes. But that's what it's going to kind of look like. Kind of looks like a, I don't know, spiders almost. Now, if I'm at 4 plus or minus 1, so if I'm at the positive 1, it's going to be up here, and it looks like it might look, I don't know, maybe that. I'm not quite sure because I didn't tick mark it that well. And if it's the minus 1, it might look something like that, maybe. Okay. So to handle that, there's definitely a difference between being the positive one or the negative one. So we're going to take a look at that once we separate and integrate. So remember, all the ticking just shows you the slope field, gives you the potential paths that you could follow. And then when you actually separate and integrate, you're actually going to get that red path or you're going to get that blue path. And that's what we're trying to find. So when you want to separate, I'm going to go dy over y equals 2x dx. Now everything's separated, so I can integrate. ln of y equals x squared plus c. Okay, now there are 2 ways to handle the plus c. If I'm trying to solve for that plus c, you can plug in now, or you can do the fuzzy math first. Okay, so if I wanted to plug in now, let me see if I can move this up a little bit. If I plug in now, you would say I'm plugging in 4 plus or minus 1, depending on which one I do. You would say ln of plus or minus 1 equals 4 squared plus c. So I got ln of 1, because plus or minus 1 absolute value is just 1, equals 16 plus c. ln of 1 is 0. So I got 16 plus c. I got c is negative 16. So my guy would be ln of absolute value y is x squared minus 16. Now, you have not solved for this guy yet. So you would technically still want to get y equals. So you would e both sides. And you would get the absolute value of y is e to the x squared minus 16. Okay? But depending on if you took the positive version or the negative version, you're going to have the plus or minus. So I really need to say here, another way to say absolute value is you could say y equals, it's either the plus or the minus version of e to the x squared minus 16. You need to decide which version it is, depending on that initial value that you're starting with. Okay, so if you're starting with the 4 comma positive one, your guy would be y equals e x squared minus 16. And if you're starting with the minus guy, so 4 comma negative 1, you'd be having to say y equals negative e to the x squared minus 16. Okay? And you can graph both of those guys to make sure they do go through 4 comma 1 or they go through 4 comma negative 1. Big thing to realize is e to the anything is always positive. So if I'm in that 4 comma 1, it has to be positive, so it's positive out front. But if it's 4 comma negative 1, well, e to anything, I promise you, e to anything is positive. So to force it down into the negative world, you need the negative out there. I went back up and I actually graphed those two types of equations on my calculator. And they look like this, but a little bit more, see if I can pull this away. They kind of look more something like this. It like really flat lines and then comes back up. Or it really flat lines this way and then goes back down. So it kind of looks like those parabolas, but really flat parabolas at the vertex part. Now, that way as I plugged in right away, now if you notice, the plus or minus 1 already got canceled out by the natural value of the absolute value, or sorry, the natural log of the absolute value of plus or minus 1, and you later had to remember the plus or the minus part later to make sure you grabbed what you needed. Let's try it this way. If I had this way, I would not plug in yet. And I would just immediately go, oh, I'm going to E both sides. And every time I've told you that, once you E, I've told you the absolute value really goes away. This is what it technically does. You would say the absolute value of y is CE to the x squared. But realize this, the absolute value breaks into two different guys. It's either the plus version or the minus version. So technically, you would be saying it's either y equals plus CE to the x squared, or it'd be y equals negative CE to the x squared. But here's the thing, positive C or negative C in fuzzy math world is still just C. So when I kept telling you the absolute value just goes away, it's because you're either going to be the plus or you're going to be the minus. But since I haven't solved for the C yet, it's still just a C. So I'm going to still say it's y equals CE to the x squared. And that minus, if it needs to be there, will pop out once I plug in. Now, if I plug in, let's say 4 comma, what was it, 1? I would say 1 equals CE to the 4 squared. So 1 equals CE to the 16. C equals 1 over e to the 16. So my guy would be y equals 1 over e to the 16th e to the x squared. And likewise, if I plugged in, it's red, for negative 1, I'd get negative 1 equals CE to the 4 squared. Negative 1 equals CE to the 16. C equals negative 1 over e to the 16. And so I'd have y equals negative 1 over e to the 16th e to the x squared. That negative is found because you plugged in y equals negative 1. I like the right way better. Some of you might not, because you might really not be comfortable with fuzzy math. But my issue with the left guy is when I E it on the left guy, I forget about the plus or minus in the end. And I would forget that, oh, since it's 4 comma negative 1, I need the minus. Because that's how that one works, is you have to remember the minus sign. I don't like remembering the minus sign. I like getting the minus sign by physically plugging in negative 1, and it comes out all on its own. So that's why I like the right side better doing the fuzzy math, because that negative 1 pops out on its own. Okay. Now, just staring at the two options here, apparently that, oh, come back to me. That is the same as that, even though it looks different. Remember, the way I could write this guy is y is e to the x squared over e to the 16. And what are you going to do with exponents when you're dividing? You get to subtract. So they are the same. All right. So just be careful with kind of in summary, the guys that you're going to need to be careful on is if you ever have a y squared equals something, when you square root it, y could be plus or minus something, and it depends on your guy. If it's a 6 comma negative 3, you're going to want that version. Or be careful if you have a, let's see, ln of y equals something. When you e both sides, technically it should be a plus or minus e to stuff. And if you have something like the 6 comma negative 3, that's going to pop out. And if you have something like y to the 3/2 equals something, and you need to raise everything to the 2/3, you do not need to worry about it because it's just going to be positive. Because remember, anything to the 2/3, when you square something, that becomes positive, and the cube root of positive stays positive, just like the cube root of negative would stay negative. There's no switching of signs there because you did not square root it. Okay? So here is your next set of homework. This will be Wednesday. Let's see, the video lecture was 20 minutes, and a 10. So that's about 50 minutes long, probably 15, 20 minutes on the board, maybe if you're doing those problems. So you'll have some time to look at some of this homework now. That's it. That's all you've learned on Monday, Tuesday, Wednesday. There is no real new material. Just tomorrow's video lecture will just be kind of rehashing, trying to go over some example problems to get you ready for the test. If you have questions, talk to Porbay or talk to Shafi. You can attempt to email me, but no guarantees. Family first. See ya.